Had any questions for the first 4 weeks of class yet? All right, let's get going. This week is week number 5. We're going to be dealing with change of base formula, which is kind of it's an outdated way of finding the logs. If you don't have a good calculator, you could use the change of base formulas, but nowadays, most calculators, you can change it to any base that you want. Even Desmos, if you go into Desmos and use the log button, it will ask you which base that you want. Now, the base change formula lets you find the log of any number. For example, if I gave you, I don't want to, let's say I asked you to find the log base 2 of, let's say, 8. We can do this in our heads. We should know that the answer is 3. But anytime the base is not 10, then if you want to use your calculator to solve it, what you do is you just type in the log of this number right here. I don't know why that disappeared there. Sorry about that. I don't know what's going on with my writing thing here. So let's try, oh, there it is. Over, and then the log of the base, so log base 2. So if you typed in log of 8, divide by log of 2, you will end up with 3. So you can do, because calculators, most calculators, the base is 10. But nowadays, you can change that. You can change it to be anything that you want. But if you do have an older calculator and the base is 10, then you can use this formula to find the log of any number that you want. Okay, so that's called the change of base formula. Most parts of this week's assignment is to be able to rewrite logarithms. What we consider properties of what we're trying to do is we're trying to get into solving logarithmic and exponential functions. And one of the ways that we do that is when we have a logarithm that is, you know, a large logarithm. Let's say I gave you something like the log, I gotta change my marker here. Let's say I gave you something like the log base 2 of x plus the log base 2 of 10 is equal to, I don't know, 5. We can condense logarithms. We can rewrite them as a single log. And the way we do that is if there's a plus sign in between, we multiply these two numbers out. So if you're asked to write it as a single log, this would be written as the log base 2 of x times 10 or 10x. These two things mean exactly the same thing. Now, if there was a minus sign there, okay, so let's say this was a minus sign, then instead of multiplying, we divide. So this would be the log base 2 of x over 10. And that goes through with, these are the, you know, they basically are expanding it out. They're rewriting it in expanding form here, okay? And natural logs work the same way. A natural log is just the same thing, but it's log base e. And then, so those are the two properties, these two properties, check 1, check 2. The power property says that if you have an exponent here, you can bring that to the front. So if I had something like the log base 2 of 8 to the 5th power, I don't know what that is, but I can really make this problem a whole lot easier by putting the 5 in front. So now I could rewrite it as the 5 log base 2 of 8. Well, I know what log base 2 of 8 is. It's 3. So this would become 5 times 3, which is just 15. So this week, a lot of the stuff that we're dealing with this week is dealing with the properties of logarithms. Okay, and these are the 3 properties that you really have to know in order to do this week's assessment. Okay, so it's just a real quick review of the lesson tutorial that you should have had. And then if you have, like, if you had exponents and the exponents base are the same, we could add the powers. Well, same thing with logarithms. That's basically where these properties have come from. It's if the bases are the same, we can just multiply the terms out. So that's where this property comes from. And the quotient property is same thing. And then the exponent power, which just means you can bring it in front, is probably one of the most useful properties in there. All right, so let's take a look at this week's practices. So this week, the practice, they look really tough. I mean, these problems look really hard. It says rewrite the expression as a single logarithm. Well, I know that in order to write a logarithm as a single log, the first thing I have to do is I have to get rid of the numbers in front. If there's ever a number in front of the exponent or the log, you have to bring it out in front. So, or up as an exponent. So this 2 I have to put here. So I'm just working backwards with that rule. And this 7 is in front of this natural log, so I'm just going to put that 7 here. So I'm using the property going backwards. I'm just looking at it and saying, okay, I got to put that 7 there. Okay, now this is all addition. So that means all of this is going to be just multiplied together. So it's going to be 6 times x squared plus 5 to the 7. So I can write this whole mess as one logarithm. So natural log of 6 times x squared times x squared plus 5 to the 7th. And that should be my answer. Now, if I can simplify, I probably would, but there's no way they're going to ask you to multiply this out, x squared plus 5 to the 7th power. That would take me a long time. So I'm just going to say my answer is letter A, natural log 6x squared times x squared plus 5 to the 7th power. Brian, does that make sense, how I came up with that answer? Okay, problem number 2. It says use the properties of logarithms to expand the logarithmic expression out. So now they want us to expand, okay? Well, this is a division sign. So I know that going the opposite direction, since it's division, it would be a subtraction problem. So this would be a natural log of e squared minus natural log of 5. Now this 2 I could bring in front, but it doesn't look like I have to. It looks like my answer is right here. Now, rarely will you ever have to expand a logarithm out. Most of the time, it's just condensing them down. And that's what we do most of the time, is we condense them down so we can solve logarithmic equations. Number 3, it says use the law of logarithms to rewrite the expression below in a form with no logarithm of a product, quotient, or power. Okay, so basically this is a quotient here, x over 6. So I'm just going to rewrite this. I'm going to expand it out. I'm going to rewrite this as the log base 7 of x minus, since that's division, log base 7 of 6. Done. And as I said, this is going to come in real handy next week when we start solving logarithmic equations. Right now, all we're doing is we're just using the properties so we know what the properties are. And then next week, when we start solving the equations, then it's like, okay, this is where we're going to have to use this stuff. Okay, so this week, pretty easy, just the properties of these types of problems. And then next week, we're going to get into solving exponential equations, which is way harder. Okay, next problem. It says use the logarithm, the law of logs, to express the form with no products, quotients, or powers. Okay, so first thing I have to do is it's like, okay, how do I rewrite the square root? Not the square root, it's the 7th root of 11. Well, I remember that it's power over root. So this is the 7th root of 11 is the same thing as 11 to the 1/7 power. So in place of this, I'm going to rewrite this as a log base 6 of 11 to the 1/7. Well, I know I can bring the 1/7 to the front. So I'm going to rewrite this as 1/7 log base 6 of 11. And that's it. I'm done, because it asked me to rewrite it without any products, quotients, or powers. Well, I don't have any powers now. I brought that power to the front. I don't have any products or quotients, so this is rewritten the way they want me to. Letter A. Use the law of logarithms to rewrite, and these problems are over and over and over again. Now this one's a little bit tougher because now it's the square, it's the 8th root of this whole thing. Now you have to be really careful when you rewrite that, because that 8th power or 8th root goes to everything. So if I had to rewrite this, I'm going to rewrite this as the natural log 6 to the 1/8 r to the 7/8 s to the 1/8. Okay, so I had to, that root goes to every single term inside. So I just put it on each one, because remember, each one has a, this is to the first power here, and this is to the first power here. So it's 1/8, 7/8, and 1/8. But now I still have products and I still have powers, so I have to break this up. It's all multiplication, so my next step, I'm going to rewrite it as natural log 6 to the 1/8 plus natural log of r to the 7/8 plus natural log of s to the 1/8. Now it still has powers because I have the 1/8, the 7/8, and the 1/8. So I'm just going to rewrite this. I'm going to bring those numbers to the front. So 1/8 natural log of 6 plus natural log, oops, I forgot to put 7/8 in front. 7/8 natural log of r plus 1/8 natural log of s. So now I don't have any powers, I don't have any products or quotients. And let's see here, what does that become? Letter D, 1/8 natural log of 6. Nope, that's not it. 1/8, 7/8, 1/8. Oh, letter A again. When in doubt, pick letter A. All right. Brian, any questions up until now? All right. If you have any questions, make sure you ask, okay? I can go through any of these types of problems if you want. All right. Next question. It says use same directions. I don't want any products, quotients, or powers, so I'm going to rewrite this. And this is where, the rules are pretty easy. It's just being able to break this stuff up. So I've got natural log of x times, and then I've got y to the 1/8 over z to the 1/8. So this is multiplication, so I'm going to break it up into two different problems. So I'm going to go natural log of x plus natural log of y to the 1/8 over z to the 1/8. But now this is a product, so I'm going to break this up. So this is going to be natural log of x plus natural log of y to the 1/8 minus natural log of z to the 1/8. Because if it's a product, we add, it's addition. If it's a quotient, we subtract. So now I still have exponents in here, so I'm just going to rewrite it with them in front. So natural log of x plus 1/8 natural log of y minus 1/8 natural log of z for my answer. I'm going to go right up to A, see if that's the right answer. Natural log of plus minus, yep, that looks right. When in doubt, we're gonna pick A. All right. Use properties of logarithms to expand the expression as much as possible. Okay. Evaluate the logarithmic expression without using a calculator. So here, first thing I'm going to do is I see that I can rewrite this as the natural log of x to the 1/6. Then I can bring the 1/6 down, so I have 1/6 natural log, of x. But I'm looking at it, and it's like there doesn't seem like there's anything else I can do in this problem. I mean, there's no way I can evaluate this expression. It doesn't have a number in there. It has a variable. So I think I'm done. I think 1/6 natural log of x is it. I'm going to go with the letter D because I can't simplify this any farther. Use properties of logarithms to expand the logarithmic expression. Okay, so, and then evaluate if you can. Now, I think I can evaluate this one a little bit farther than the last one. I'm going to rewrite this as log base 3 of 3 plus, because this is a multiplication here, so I'm going to rewrite it as two separate problems, plus log base 3 of x. Okay, now this, I know what that is. Log base 3 of 3 is just 1. Because 3 to the first power is 3, plus log base 3 of x. Now, I can't do anything with this thing. There's no way I can simplify this down because I don't know what x is. So I'm just going to leave my answer as 1 plus log base 3 of x. which is letter C. Not even sure what problem we're on here. All right, next one. It says use properties of logarithms to condense. Okay, so now condensing is where usually most of our focus is on. As I said, when we start solving logarithmic equations, the thing that we really want to do is we want to condense the logarithms out. So this is really a crazy problem. So the first thing I'm going to do is I'm going to look at it and it's like, okay, I want to try to condense this thing. So I'm going to rewrite this here as a single log. I'm not going to touch the 1/6. I'm at 1/6, and then I'm going to rewrite it as log base 2 of xy. Okay, minus 2 log base 2 of x plus 9. Look like there's a lot I can do here, but I'm going to bring that 2 over to this side. So I'm just going to go log. Do I want to do that? Sure, I'll do it. Okay, and now it's like, oh, I've got 2 logarithms, but I still have that 1/6 there, so I'm going to put it up here. And now I can condense these 2 logarithms because there's a minus sign in between, so I'm going to rewrite this as a log base 2 that x and y is to the 1/6 divided by x plus 9 squared. So now I'm looking up there and it's like, okay, if you think about it, x plus y to the 1/6, I'm sorry, xy to the 1/6 is exactly the same thing as the 6th root of xy. So I'm looking at this letter C as the answer that I'm looking for. Okay, and as I said, condensing is the thing that we're really going to work on next week when we're trying to solve, because this might have been set equal to 10. And it's like, okay, now then this would be equal to 10, and then I could rewrite this as an exponent, so that would be 2 to the 10th is equal to this. So that's where we're headed. We're headed to solving much harder equations. But this week, just the properties of logarithms to get you ready for next week. Next week will be, as I said, definitely much harder. All right. Use the properties of logarithms to expand. Okay, so now if there's not a base for a log, it is assumed to be 10. It's not even assumed, it is a 10. So I'm going to rewrite this as log of 10, log base 10 of 10,000 to the 10,000x. I'm going to rewrite this as a, since it's a multiplication, a plus sign. So that's log base 10 of 10,000 plus log base 10 of x. Now, log base 10 of 10,000, isn't that just 4? Because 10 to the 4th power is 10,000. So this is just 4 plus log base 10 of x. That would be simplified as far as I can take it. And I believe that was problem number 10. Brian, any questions on any of that stuff that I just went over? All right, that is it for this week. As I said, next week, much harder. Next week, we're going to take what we've learned using the properties of logarithms, and then next week, we're going to be solving equations. So it's going to be definitely a little bit tougher. Hopefully, we'll see you tomorrow or next week, Brian. Have a great week. Bye.